This is today, and today we are going to see analysis for car aerodynamics analysis. So we develop a profile of car in SolidWorks, and we import that profile to ANSYS, and we develop car aerodynamics analysis. So first we open the ANSYS, and we got like this. This is the ANSYS profile. So in this ANSYS profile, we open this one, fluid flow. So because we are going to see the flow of air on the body of the car, so we open this fluid flow, and this is a fluid flow by Fluent. So the geometry in here, first we right click on the geometry and add the geometry which is from the ANSYS. So we add it in here in geometry, and we open it in here. So after geometry we have like this. So we develop like this, which is in here. There is a geometry inside this. You can see this box is enclosure, so like wind tunnel. So inside there is profile of the car. So this profile was imported from the SolidWorks, and so it places inside of the box. The box is the solid part or the enclosure, or like it becomes like a wind tunnel. So in here, this is the imported car, and this is the enclosure, which is wind tunnel, like act as a wind tunnel. So we can demonstrate, or we can analyze the profile of the car by fluid flow, which is in this case, which is air. So we develop all this. What we done is as you can see, this is the box. The box is an enclosure as a wind tunnel. Inside there is a profile car. So we are going to make this face as an inlet, and this face as an outlet, and in the top the rear one, and the bottom as the walls, and this one as symmetry, because this box was not like this, and this is half of the box which is developed in here, because it is symmetry. So if we made on the half of the car, then we can find on the whole car, because it is symmetry along the YZ plane. So it is symmetry in here. As you can this is a symmetry. So half of this box is removed, and the half is going to be analyzed in here. So this is a developed geometry, and the mesh is like this. As you can see here, this is the mesh. In here we can say, in here right click mesh and edit. So we can edit the mesh, and will give us like this. So in a mesh, as you can see in here, so in mesh we do like, let me proceed with this. So this is the profile. After the mesh, here is the mesh. We can see different directions. So these things, this is the inlet of the car. So if this is the mesh. So it have a profile of the car inside. So we can see the inside this one. You see the profile of the car is in here. As you can see, the profile of the car. This is developed. This one is the like the wheels. So we have the profile inside. So we have the inlet of the car, or the box here, the inlet, and the walls, this one. That's the bottom, the rear, and the top one. And the symmetry is this one, because this is the half of the car, because it is symmetry along the YZ plane. So if we made on the half of the car, we can make on the whole part of the car, because it's symmetry, it's the same. So this is the car inside, the profile of the car inside, and then you can see this. So this is the outlet. I mean, this is the inlet, and the outlet is on the back of the car. So we can proceed having this mesh to the analysis. On the analysis, we can say in this setup, we can check the setup of the analysis. Then when you open the setup, we can find like this one. So in here, what we are going to do is make the materials. We choose the material and the models in here. The model has to be a viscous K epsilon T equation model, and these things a standard wheel function and standard K epsilon model. Next to that, we need to choose the material. The material should to be an air, so we can check material in here. So it is an air because this is not a solid. If it becomes solid, so we can choose an aluminum and another material, but in this case we are using air, so material we need to check it is an air. So in here, in the inlet has to be velocity, so the velocity should be like an averagely 20 meter per second. This is an average car velocity, so we use 20 meter per second of an inlet air velocity. Again, the outlet has to be pressure outlet. We need to take that one, and this is pressure outlet, so leave like this. And method, use in here a method. The method should be coupled in here, coupled, and as you can see, we can use the second order upwind for momentum, turbulent kinetic energy, turbulent dissipation rate, and the gradient is least sail based. So we use on a calculation 100 iterations. So this is 100 iteration with, and we proceed to calculate the results of the mesh. So in here we use monitors for the residual, because we use 100 iterations. These things will make, let me show you this one. These things, if we check these all things, then they will make they will stop before it reaches the 100 iterations. So we uncheck them and we can have 100 iterations. So after that we use we get this one. This is 100 iteration of the velocity, the iterations, and in x velocity, y velocity, z velocity. We get like this, and we proceed to the post analysis of the problem. So this is the solution, and we proceed to the results.